Welcome to qnawire.
Hello friends, here it is given. Two L-shaped arms, each of mass 5 kg, are welded at 1/3 points of 600 mm shaft AB to form the assembly. If assembly rotates at constant rate of 360 rpm, that is 12 pi radian per second, we have to calculate angular momentum of the assembly about the point A. The angle formed by angular momentum about A and AB that we have to calculate. Now let us start solving it. Here omega x is 0, omega y is 0, and omega z is 12 pi radian per second. Angular momentum about the centroid G as shown in the figure along x-axis will be minus Ixz omega, along y-axis minus Iyz omega, and along z-axis it would be Iz omega. We can divide the assembly into 4 segments. I am marking with here blue color. 1, 2, 3, 4. Mass of each assembly will be, each segment will be half and side will be A. This can be marked as A. Let us see here. Say this is equal to A. This is A. This is A and this is A. So I am writing here, given assembly has to be having 4 segments marked 1, 2, 3 and 4. Mass of each segment is m by 2, that is 5 by 2, so 2.5 kg, and side A is 200 millimeter, that is 0.2 meter. So we will write the moment of inertia of each segment and we are tabulating it. Part in YZ plane, in XZ plane, in IZ. Let me correct it. This is XZ and this is to be YZ. It is in materialistic. Segment 1, segment 2, segment 3, segment 4, and summation means assembly. Assembly 1 having a moment of inertia in xz plane minus half m dash a square, in yz is 1 by 4 m dash a square, and along z axis it is 1 by 12 plus 1 by 4 plus 1 m dash a square. Assembly 2 minus 1 by 4 m dash a square 0 1 by 3 m dash a square. Third assembly minus 1 by 4 m dash a square 0 1 by 3 m dash a square. Fourth assembly minus half m dash a square 1 by 4 m dash a square 1 by 12 plus 1 by 4 plus 1 m dash a square. If we find the total of the assembly, it will be adding all these, you will get minus 3 by 2 m dash a square half m dash a square 10 by 3 m dash a square. So here we can write angular momentum of centroid along x-axis. You may write minus 3 by 2 m dash a square omega, minus minus it becomes plus, m dash is 2.5 kg, omega a is 0.2 meter, and omega is 12 pi. So this value will be 5.6549 kg meter square per second. Similarly, along y-axis, half m dash a square omega, m dash having the value 2.5, a is 0.5, and angular velocity is 12 pi radian per second. So angular momentum of centroid along y-axis minus 1.8850 kg meter square per second, and along z-axis 10 by 3 m dash a square omega. So it will be 10 by 3 m dash 2.5, a is 0.2 meter whole square, and omega is 12 pi. So here you will get 12.5664 kg meter square per second. So velocity of center of mass is 0, So angular momentum of the assembly about the point A can be defined as angular momentum about the centroid plus position vector of A with respect to G cross MB. Since velocity of center of mass is 0, so this term will be 0. You will get 5.65 I cap 1.885 J cap plus 12.5664 K cap kg meter square per second. So this is one of the answer we have obtained. This is the answer of part A. Now answer of B. Magnitude of angular momentum about A will be square root of 5.65 whole square 1.885 whole square 12.5664 whole square, so you will get 13.91 kg meter square per second. So angle between AB as a shaft and angular momentum can be defined as HAZ upon HA. Substitute the value 12.5664 upon 13.91, so the angle will be 25.4. That's all for it. Thanks for watching it.